Welcome to Learn With Me channel. If you haven't subscribed it yet, please subscribe the channel. Today we're going to look at some basic arithmetic and we'll be looking at prime numbers. Prime numbers play a crucial role in various fields. Here are some uses of it. It's used in cryptography and cybersecurity, computer science and coding, banking and financial security, where the credit card transactions and online payments are secured, error detection and correction, to find a QR codes, barcode, they use in barcodes, science and engineering, used in signal processing to filter unwanted frequencies in communication systems, help in modeling natural patterns such as in biology and physics. Music and sound is used in music and sound engineering and also used in nature and biology, architecture and design. Prime numbers are not just theoretical concepts but have practical applications in technology, security and nature. We're looking at the prime numbers, number two, prime factors, and then highest common factor, and the lowest common multiple. So, what is a prime number? Prime number only have two factors, one and itself. It cannot be divided by any other number. So, for example, you take 4 can be divided 2 times 2. So, the prime numbers are 2, 3, 7, and so on. Prime factors are the prime numbers that multiply together to give a particular number. In other words, prime factors are the prime numbers that divide a given number exactly without leaving a remainder. Let's find prime factors of some numbers. For example, first 12. 12 is an even number, so we'll divide with 2. When we divide with 2, it gives us 6. Then 6 is divided with 2 again, gives us 3. So the prime factors of 12 are 2 times 2 times 3. And it can be rewritten as, because there are two 2's, so we could write as 2 square times 3. So the prime factors of 12 are 2 square times 3. And now prime factors for 30. 30 is an even number, which you can divide by 2, gives us 15. 2 times 15 is 30. And then can be divided by 3 and 5. So the prime factors for 30 is 2 times 3 times 5. And let's find prime factors for 144. So it's an even number. We divide with 2, gives us 72. Divide with 2 again, gives us 36. And 36 divided by 2 again gives us 18. and then 18 divided by 2 again gives us 9, and 9 divided again 3 by 3. So in this case, prime factors of 144 are 2 to the power 4 times 3 to the power 2. So it's okay. Now let's look at 210. 210 is also an even number. We divide by 2, which gives us 2, 105, and then 105 divided by 3 will give us 3 3s are 9 and 3 5, 35. 35 can be divided by 5 and gives us 7. So the prime factors of 210 are 2 times 3 times 5 times 7. So these are the prime factors of 210. Let's look at the highest common factor. The highest yes, that's correct. Highest common factor, HCF, of 2 or more numbers is the largest number that divides all of them exactly. To find the HCF of 2 numbers, first find prime factors of both numbers. Number 2, identify common prime factors from both numbers, which are all the numbers which are common to both sets, and then multiply these common numbers together. So if we are, let's do some examples. Find HCF of 12 and 18. So 12 is even number, 2, 6, and 3 and 2. So the common factors are 2 squared times 3. And prime factors for 18, even number divided by 2 gives us 9, divided by 3 and gives us 3, so we have 3 of them. So 2 times 3 square. Now, to find the HCF of both numbers, we're looking at what is common in between these two. So there is a number 2, only 2, 1 2 in both of them, and 1 3 in both of them. So it's 2 times 3. Yeah, 2 is common and 1 3 is common. So that'll give us the HCF of 12 and 18 is 2 times 3. Because there is a single 3. Only 1 3 in both sets. So when we multiply with 2 times 3 gives us 6. So the HCF of 12 and 18 is 6. Let's find the HCF of 42 and 63. Get the prime factors of 42, which is 2, 21, and 3, and 7. So they are 2 times 3 times 7. So these are the prime factors of 42. And 63 is not an even number, so not an even number. So not 2, we'll divide with 3, which will give us 2 3s are 6, and 1 3 is 3. So it'll be 21. 21 further divided by 3 will give us a 7. So the prime factors of 63 is 3 squared times 7. Now we'll have to look at what is common in these two sets. There's no 2 in the second one. There's 3 in both of them, only single 3. So we'll take that 3, and then there is a 7 in both of them, So we'll take 17. So the HCF of 42 and 63 is 3 times 7, which is 21. So HCF of 42 and 63 is 21. The next example, we can look a couple more numbers. Find HCF of 56 and 72. Again, even number, 56. So you keep dividing by 2 until you end up with 2, 2, 2, and 7. So 2 cubed times 7. These are the factors for 56. And 72 is an even number. We divide by 2 and get 36. And then 36 also even number. Keep dividing, even number, keep dividing by 2. And then 9, you go to 3 now. 3 3s are 9. So the prime factors will be 2 to the power 3 and 3 square. And now the HCF is the common number which has in both of them. So 2 to the power 3 is in both of them, so we'll take that 2 to the power 3. And the 7 is not in the second set, and 3 is not in the first set, so we won't take it. So the HCF will be 2 cube, which is 8. So HCF of 56 and 72 is 8. Okay, let's do one with 3 numbers. 11, 22, and 44. So 11 only has one factor, which is 1 in itself. 22 can be divided because it's an even number. Divided by 2, which is 11. So it'll be, factors will be 2 times 11. And 44, even number, can be divided by 2. And still 22 even number, so it'll be 2 times 11. So in this case, it'll be prime factors are 2 squared times 11. So now this time we're going to look at what number is in all 3 of them. All the numbers which are in 3 of them. So in the first one there is 11 and it's only one number. So all 3 of them have 11. So in this case HCF will be 11. So the HCF of 11, 22 and 44 is 11. Let's look at the common multiples. Lowest common multiple, LCM. The lowest common multiple of 2 or more numbers is a multiple of all the given numbers. Find the prime factors of each number. Take one copy of the common factors, which are in both, as we did in the HCF. And then in this one, you'll have to take the other numbers which are in one set but not in the other set. Also take the remaining factors from both sets. So we've taken the common, and then what's remained, we're going to take that as well. And then multiply all common factors and remaining factors together to get the LCM. So let's do some example of LCM. So we pick up 2 numbers, 144 and 210. So get the factors, prime factors first. which is 2, 72, 2, 36, and then further on 18, and then 9, then 3 and 3. So the prime factors for this will be, 144 will be 2 to the power 4 times 3 squared. And now 210, do the same treatment with that. It's an even number, divided with 2. It gives us 105. And now it's not even number, we divide, try 3. 3 3s are 9, yes. Right, 3. And is 3 3s are 9, and 3 5s are 15. And then divide by 5, which gives us 5 and 7. So the prime factors for this are 2 times 3 times 5 times 7. Yeah. So first we find the common factors in both of them. So if you look, there's a 1, 2 in both of them, and 1, 3 in both of them. One, 2 is there. And let's draw the boxes for remaining factors for both of them, which are 2 squared. In the first one, 2 cube. 2 cube is not in the other one. And then times 3 as well. In the first box, in the first set of factors, so 2 cube, the remaining. Remember that one we have used in the common factor, the middle box, and the remaining there were 3 2s and 1 3 extra in there, R1. And the second set, there's a 5 and 7 which are extra. So R1 is 2 cubed times 3, and R2 is 5 times 7. Now we have to multiply these, all the numbers in the common box, common factor box, and all the number in the remaining boxes. So it's 2 times 3 is the common box numbers, and then R1 is 2 to the power 3 times 3, and then time the R2, the remaining from second set, which is 5 times 7. Now you have to multiply all of them together, which will give us 6 times 24 times 35. So if we multiply 24 with 6, it gives us 24 times 6 times 35. 24 times 6 gives us 6 to 24, 1444 times 35. Let's multiply them on the side. 144 times 35, 5 4s are 20, 4 5s are 22, 7, 3 4s are 12, 3 4s 12, 13. So that gives us 5040. 144 times 35, yeah. So the LCM for these two numbers is 5040. And that's the end of it. I hope you learned all about prime numbers, prime factors, highest common factor, and lowest common multiple. And if you haven't subscribed the channel, please subscribe the channel. I'll see you in the next video. Thank you for watching. Bye for now.